Hello everyone. I'm in Minnesota right now while you're sitting in class getting your learn on. So let's figure out what the heck we are going to do. We are going to start by taking a quiz. You probably have already taken a quiz. And we are going to discuss two topics today. And I'm here with you, but I'm recording this without any of you around me, which is different. But let's go into our two topics. We're going to talk about phototransduction today and another topic called rods and cones. I would like to prepare all of you for our next class. Let's see, Monday or Tuesday, depending on when you are listening to this video. We are going to dissect some cow eyeballs. So get jacked up. It's going to be awesome. Maybe we'll have some people pass out. I don't know. It's going to be exciting. Okay, so our objective for today, and really for the next couple of topics, we're going to be talking about vision. So we are going to explain the complexities of vision. That is our focus. Okay, now this is not something that we're going to be able to accomplish just in one topic or two topics. We've got to because vision is our strongest sense, we're going to actually do this in a whole bunch of different ways. So we are going to obviously learn about it in class. We are going to have my buddy Hansi, Dr. Hansi, in. He's an optometrist. He's going to talk to us about everything vision and some interesting stuff that we don't know about, and maybe ask some questions and whatnot. We're going to cut into a cow eyeball because many of the anatomical parts are very similar to the ones that you have in your eyeball. And then, we'll obviously go through some of the anatomical parts through charts like we've done in previous units and topics and all that fun stuff. So our objective is to explain the complexities of vision. Let's get this party started. Unit number 2, I like to think that each unit gets a little bit more exciting. When we start off in unit number 1, we begin with where did psychology get its beginnings? All right, so we talk about the history, talk about the foundation of psychology, and then briefly we go over some of the fields of psychology. And I get that some of that stuff isn't super engaging all the time. That's why we do things like the whole slippery snake activity to kind of make it a little bit more engaging. But in unit number 2, we're going to talk about perception. So in part of perception, I get this from a lot of kids' parents when we talk about looking at vision in psychology, is clearly, seeing the object's one thing, but what our brain's going to do with that. So how we perceive certain stimuli, certainly quite interesting. We're going to talk about consciousness and different levels of consciousness. What happens when we sleep? What about when we get hypnotized? We're going to do a hypnosis lab, which is awesome and exciting. So that'll be fun. And then we're going to finish this unit with memory. How do we remember things? Why is it that I feel like I have a distinct memory of a friend of mine who's now a psychologist in California? When we were in, I don't know what would have been, 4th grade, we were sitting down at the table, and she had one of those Lunchables. I love this story, by the way. She had a Lunchable, and she was so excited. And I don't know why I know this or how even Lunchables had this, but anyway, she's trying to open up this little packet of lemon juice, right? And she's going through it, and she tries to open it up, and it squirts into her eyeball. I think that might have been the first time that I remember laughing so hard that I started to cry. It was awesome. Such a great story. But I do know that memory has also been manipulated through time. And we're going to talk about that, like false memories and how our memory can change and a whole bunch of stuff, memory. But we're going to begin in Chapter 4, Vision. So you should have your notebook out. We're taking notes right now. I'm with you. I'm right here. You can't ask questions, though. This should be a video, so if need be, we can pause, I think. This might be a link on YouTube. I don't know. I haven't figured that part out yet, how it's going to be delivered to you, but we'll get into it. Topic number 17 is phototransduction. That's a fun word for you. Where we're going to actually begin with, when I get back, we're going to ask this question. What questions do you have about vision? Some of you that didn't skip my class you know that we started with, we graded our test last time, and someone's got introduced to something called face blindness, which is a really interesting thing. And Dr. Hansi will talk to us about that as well. But anyway, let's get back to it. So we're going to start by, what questions do you have about vision, and what do you want to know more about? And then we're going to pose those questions to an expert, someone that went, is a doctor, Dr. Hansi, and then, yeah, it'll be awesome. So we'll come back to that. So as we talk today, if something is like, whoa, that's bizarre, or that's kind of interesting, please jot down anything you might be curious about, right? Because if we're going to learn anything, it has to start with curiosity. Don't just sit there and be a zombie, you punk. Now, a fun little beginner funtivity. I did this with what are they in 7th hour, I think, already. So for those of you that are not in 7th hour, if you would, please take out your phone, or you might be watching this on your computer. Just open up a new tab and just do a quick Google search of globe luxation. So go ahead and pause me right now. Okay, if you're back or whatever, you didn't pause me soon enough. When you do get back, globe luxation, that's a pretty fun thing. Literally, your eyeballs come out of your eye sockets. If you just read Wikipedia version of globe luxation, go ahead and click the images. That'll get you jacked up. Right? So lots of weird stuff happens with our eyes. Fun stuff. All right, now let's get into actual note part. Vision is not simply seeing an object. Like, it doesn't just happen. That's why I get questions like, well, why would you talk about vision in psychology? That doesn't make a lot of sense. There is so much going on. And as we talked about in our first unit, everything psychological is biological, right? So we know that there's a lot of biological functions that are involved in our perception and eyesight in general. So what actually goes on, and sorry, it looks like one of my images is in the way. No, I can't move it, so that's all right. So what's taking place for you to look at this video right now is light is bouncing off of an image, like the screen, right? Your screen is emitting light, and that light is bouncing off, or at least is entering your eyeball. And it goes through the cornea, and we're going to talk all about anatomical parts, but it goes through the cornea, and depending on how much light there is, your pupil will automatically get bigger or smaller, kind of like a camera, right? A camera shutter, or not the shutter, but if you're zooming in to get more light in, whatever. Your pupil automatically does that due to the autonomic nervous system, as we talked about in our last class, or our last unit. And if it needs more light, right, your pupil gets bigger. If it doesn't need as much light, or if there's a whole bunch of bright light shining at you, like someone shines a flashlight in your eyeball, it gets a lot smaller, right, because you're trying to control that image so you can see something. So that automatically happens. You have this automatic focus in your eyeball, which is pretty awesome. But then it goes through that hole and through this stuff called the vitreous, right? Before that there's a lens, which is like a magnifying glass, and that shoots the light back through this vitreous, and it tries to land on the back of the eye, which is referred to as your retina. Okay, well then what takes place? The image is going to be upside down on that retina, which is kind of interesting. Why does that take place? Think of it kind of like a mirror. Anyone's looked through like a telescope before? Mirrors move things upside down, right side up, do all that fun stuff. So think of that like as the lens, like a telescope that's going through your eyeball. And it places that image upside down on the back of that retina. On that retina, that light is then going to stimulate some of the receptors that we have on that retina. It's going to give a chemical signal, which is then going to be converted to an electrical signal, just like a neuron. So we're talking about neurons here. So all that stuff we learned in the last unit with the dendrites, the cell body or soma to the neuron, firing down the axon terminals, going on to the next, right? That's the exact same stuff we're talking about right here. But now it's in your eye. And that, of course, is going to be following the optic nerve in your eye. And interesting about that optic nerve is your left eye or right eye, right, is going to cross in your brain and go to the opposite side of that brain. So that electrical signal is going to be traveling through the optic nerve, and you can kind of see all this fun stuff right here, you know, how that optic nerve is. And it's also, like, what's interesting, I taught this in my 7th hour class, our eyes are slightly slanted in, right? So we can see our nose all the time. It's always present there. But our brain, just to kind of show like what power our brain has in this vision thing, it blocks out your nose. And you can tell that you see your eye. All you have to do is cover up one eye right now and look, right? And there your nose is. But when you see both, your brain automatically blocks out that nose, so you don't have this big stinking nose in the way all the time. And that's in part the whole, we're going to talk about different cues that our eyes kind of use to see different things, which is why our eyes are going to be slanted ever so slightly. Okay, in this image right here, you can see that tree is upside down, right? So the light's entering through there. Those of you that have contacts or glasses and whatnot, the reason why you have that, like if you're farsighted or nearsighted, is because that lens that you can see pictured right here, this lens, is delivering the light. It's just not getting the pinpoint light on the retina in the right spot. Like it's either stopping here or maybe the focal point would be here, so you can't really see it. So that lens is going to make it kind of cone-shaped where it's actually supposed to be, so then you can actually start to see. So that's why and how glasses work. But anyway, the electrical signal is going to be processed in the brain, of course, in our visual cortex, which lobe is responsible for processing information? Ready, set, answer. Remember, FPOT, frontal, parietal, occipital, temporal. And of course, the answer is the occipital. Okay, and there we are going to start to process that information, and it allows us to perceive what we have. But vision is not just seeing, right? And it's not just perceiving, but it's actually this interplay in between both, right? It's sensation, right? So the the light stimuli is going on our retina, which then all of that information gets processed through, chemicals and then electricity, right? So there's sensation and there's perception, and the perception part is incredibly fascinating and complex, and we'll talk all about that stuff too. So the sensation part, this is what converts images on the retina into those neural impulses, all that stuff that we talked about with neurons and the firing of those neurons and all that fun stuff right there. Okay, that's sensation. So when I say senses, like what your senses are: touch and smell and hearing and eyesight, and seeing dead people, whatever it might be. That's the whole sensation part. Perception is when we actually process that neural impulse to get meaning from them. And dang it, my prep just ran out, so I'm going to have to pause this here. So processing that information. So what color is the dress? Is it blue and whatever, or is it black and yellow? Right? We all perceive that differently, which is really interesting, and we're going to talk about that in a future class. That's the perception part, right? And I guess I already answered my question here. Can we perceive things differently? Dang it. All right, but the answer is, of course we can, due to our experiences, which is why we see color differently and why we see a whole bunch of different things. There's experience is really the reason why we perceive things a little bit differently. And this video is a great time for me to pause, right? This is a pretty interesting video that's going to talk to us about what actually goes on when we are looking at stuff. So let's see if I can stop this thing.
Sight, a precious gift we can't take for granted. Our eyes are windows to the wonders of the world. All we know and love, experience and discover, ponder and cherish. Let's peer into the workings of the eye, a unique and self-sustaining system. The reflected light of the world enters through the crystal transparency of the cornea, aqueous humor, lens, and vitreous humor to project onto the photoreceptors of the retina, whose impulses converge on the optic nerve, and then to the brain to be transfigured into imagery and imbued with meaning. Continual adjustments to the pupil and lens regulate the entry and focusing of light. In today's world, the eye's surface is constantly challenged to protect itself and adjust to changing conditions. Every blink helps our eye's natural defense system, the tear film, retain moisture and maintain visual acuity. Tears contain potent natural disinfectants to keep bacteria at bay. And the tear system washes away impurities to maintain eye health. The miraculous biology of our eyes inspires us to develop ways we can protect and maintain comfort for these remarkable structures. For all the wonders our eyes provide throughout our lives.
Okay, so in that, it kind of talked us through some of the processes, how light is reflected back to our retina and the stages that it goes through. Okay, now in our last class, we had you guys fill out that chart. Okay, and we're going to do that again, and we're going to just talk through that. So if you have that chart, or if you don't have that chart, make sure you grab one up here. But we're going to go through these parts of the anatomy of the eye: the cornea, the pupil, the iris, the lens, the retina, and the vitreous. They're the ones that I want you to know. Like, we could, of course, get a lot more complex in the eye, but we're going to give us kind of a baby version into it. So let's go to that chart. For those of us that have not filled this out, the part that we are, the thing that is maybe most interesting about the eyeball is going to be the lens. Okay, and the other thing that's pretty dang interesting is the pupil, because it acts like this thing that is constantly trying to focus and allow light in and not let as much light in. So, like, for instance, when Dr. Hansi comes, he likes to do this thing where you cover up one eye, and with a partner, you're going to shine a whole bunch of light into one eyeball. And what you're going to see is the eye that's not getting any light due to the autonomic nervous system, it's going to get really, really small, right? Because it automatically happens. It doesn't want as much light in on that retina, so we can see things a little bit more clear. So that pupil, it's very important what happens there. That's constantly adjusting to the environment that we're in. And then, so we have this outer layer, that's our cornea, is the outer layer. The eye color is the iris. Okay, so this cornea is a pretty thick protective shield, and when we cut through in that cow eyeball, you're going to see just how thick it is. It's kind of hard to go through it. We'll cut that thing right across, and we'll get into the goods. We'll be able to see the the aqueous humor that'll be in it, but then also the pupil. And then you're going to find this little hard marble-like thing, and that'll be the lens, which is our magnifying glass for light that shoots that light back to the retina. Okay, and because our retina attaches to the optic nerve, we have a blind spot, and we're going to find our blind spot. Not in this class, but I think in the next, or excuse me, not in this topic, but our next topic. So that'll be the optic nerve. We'll go through that. The retina is going to be this really thin sheet of cells in the back of our eye, but there's actually 16 layers to that retina, which is kind of interesting. Okay, then we have all this other fun stuff that we talked about, okay, in that video. Everyone's got that stuff filled out? We're ready to rock? Okay, so let's get into what is the topic we're going to talk about, and that'll be phototransduction. All that stuff that we've already discussed, how the eye sees things is incredibly important into phototransduction. Now we have to know all that stuff before we understand this. Phototransduction is going to be the process by which stimulus energy is going to be converted into neural energy. Right? So it's like we have this converter in the back of our eyes, our retina, and then it undergoes a process where we take visual stimuli and we transduce it into a language that our brain can understand. All right? This is called phototransduction. Phototransduction is going to be how we convert visual stimuli into something that our brain can understand, which is, of course, the language of our brains and our nervous system is neurons. neurotransmitters, electrical impulses, chemical process neurotransmitters. Okay, so we call that in the eyes phototransduction. And this is an interesting image because we can kind of see that optic nerve, right? And the thing that's kind of wild for my people that were in our last class is our eye, our visual field, our eyeballs are slanted in just a little bit. You can't really tell when you look, but our eyes are slanted in. That allows us to see depth perception. It allows us to make things, 3D. Because if we only have one, it's a lot harder to tell how far things are apart. So our eyes are slanted in just a little bit, and due to the fact that they're in a little bit, if you cover one eye, okay, you can see your nose, right? Everyone can see your nose without even looking, right? Just looking out there, recognizing, you kind of have to tell your brain, hey, there's a nose there, right? Well, you can do that on both sides. So constantly, our brain is being bombarded with this big schnoz, right? So what our brain does is it blocks it out. So when you open both eyes, you no longer see your nose, okay? But our nose is always seen in our visual field, but our brain blocks it out. We'll talk a little bit more about that. Okay, so what's going to end up happening with phototransduction is the light from an object is going to go to the back of the retina, right? We already talked about how it goes through the cornea. It's going to go through the aqueous humor, which is this little fluid stuff behind the cornea. It's going to go into the pupil, depending on how much light wants to be let in. And then it's going to shoot through the lens, which is that magnifying glass. And it's going to go through that translucent, jelly-like substance, which would be the aqueous vitreous. And then it's going to land upon the retina at the back of the eye. Okay, so the light from an object stimulates those receptors on the retina. Those are going to be rods and cones. We'll talk about those in our next topic here, which then is going to be transduced into the language of our brain. Right? And this is the process at which allows us to interpret that visual stimuli. Phototransduction. So it's kind of an important deal there. But the main theme here is light. Right? That's going to be our focus. And that takes us through our first topic. So if you would, please open up your text packet. Good. All right, here we go. Let's go to our next one. Okay, on the retina, right? We talked about the retina. We know it's on the back of the eyeball. There are something like 16 layers to the retina, a lot of them. But we are going to focus on just two cells, what make the bulk of those layers. And that is going to be on rods and cones. And each type of cell does something different. So the receptor cells in the back of the retina, where that light is going to go on, okay, when you cut into that cow eyeball, right, the first order of business that they're going to have you do, they're going to have you cut into the cornea. There's going to be a little bit of fluid that comes out there. And then it's going to be kind of really hard because the outer layer of the eyeball is pretty difficult to get through. So we've got to puncture that eyeball, and in that process we want to make sure that Ms. Pekash is texting her boyfriend over here. What'd you tell him? That is disgusting. You're dating your brother. It's illegal. Let's go to what we were talking about before Ms. Pekash was texting her boyfriend brother. On the back of that eyeball, or excuse me, when we cut into the eyeball, we're going to cut it in half. And there's going to be some vitreous that might, ooze out a little bit and might get on you a little. But when you clear all that stuff out, you're going to just kind of have like a half of an eggshell, basically. And there's going to be like this, also going to look like a really thin layer of skin on the back of the eyeball, and that's going to be the retina. So we'll be able to pull that stuff out, and it'll just be kind of hanging through, and you'll be able to just kind of like peel it off, kind of like chicken skin almost, so it'll be kind of interesting. But that retina covers this entire back part that we'll be able to peel off. Okay, and in that retina we will have rods and cones. Rods are going to be located on the periphery of the retina, right? So great image, located right here of the rods, right? We can see exactly where they're located. And for that, what they are responsible for, if we were to go outside at night, right, in dim light, okay, our rods are going to be activated because they are able to see things in darkness, but they can't send messages of color. They don't code for color. So although, certainly we've got cones, and we're going to talk about them, that's going to send us out color, but the rods are going to be responsive that allow us to see at night. Now, when we cut into that cow eyeball, there's going to be a reflective shield on the back of that cow eyeball that allows cows and other animals to see at night. Like if you've ever, if any of you have, a cat, you'll kind of see like this thing in their eyes. That's what you're going to see in cows as well. Humans, of course, don't have that, so we don't see so well at night. But when we do see at night, it's because our rods are what are activated. Yes, Dylan?
How come in some pictures your eyes are red?
Oh, true.
I don't know the answer to that. That's going to do something with the camera, not our eyes actually being red.
Since the rods and cones are arranged in that, is since our eyes the pupil dilates when we don't have enough light, does it go over the rods so that we can use our rods, and then when we have a lot of light or just regular light, it just is cones?
So it's trying to access the part of the retina that is going to be utilized. Yeah, so exactly. The rods, here's a good way for us to think about this, okay? Rods, we can't really see a lot of visual acuity. We can't make out details at night because our rods aren't great at that. Cones, though, right? If you think of a cone, they come to a point, right? So I'm going to focus all of my attention on Miss Wareham right now, utilizing my cones, because cones are at the center of the eye on our retina. They're very good in bright light. They allow us to code and to see color, right? And think about all of the colors that our eye can see. There are literally thousands of combinations of color that our eyes can detect. And Mr. Igo, what were you saying last class about shrimp, was it?
Oh yeah, they have 16 more cones than us, so they can see other colors.
Okay, so there is a whole spectrum of color that we can't actually pick up on. It's just like how dogs can hear things that humans can't, right? There are going to be other, Obi, what's up, young lady? There's going to be other, not just sounds, but also visual stimuli that we can't pick up on. Okay? Now, when we talk about color, let's look at our eyes having 3 types of color cells. Okay, and it's going to be this combination of which cells get triggered that allow us to differentiate between colors. Okay, but our different types of color cells are going to be red, green, and blue. Now this kind of begs us to a question. Let's skip ahead here. Okay, do we have anybody here that is or has a family member that is colorblind? All right, so are you or just a family member?
My dad.
Your dad?
Dad and brother.
Okay, boys tend to be colorblind a lot more than girls, right? It does run in families. And what that is, and Dr. Hanzo gives a lot better explanation of this, but it is going to be, whatever color they are blind to, it's going to be a deficiency in the cone that is to receive that information, so the receptors. So we've got red, green, and blue receptors on the back of that retina.
You can just buy glasses now, though.
They can do that?
Yeah.
I didn't know that. My dad is colorblind.
No, these special glasses.
Yeah, that's interesting.
It's dope.
It's super dope, man.
It's pretty steezy.
That's super drugs.
Jesus Christ.
Man, that's so drugs.
Jeez.
So heroin. So heroin. Cocaine.
That's so crocodile.
Yeah. Okay, so let's talk about now, when we look at how do we go from retina to perception, from retina to our brain to perceive information. Okay, so in order for a receptor to send a message to the occipital lobe, which we all know, hopefully, because we know our lobes, remember FPOT. Okay, what's F stand for? What does this do?
We have to learn another topic.
What happens right behind our forehead? We talked about a guy who took a stinking pole right through the forehead. Okay, our personality, our decision making happens right here. Okay, what does the P stand for? Parietal. Right? Memory storage will be in there. Now if we go to the occipital lobe, what happens there? Our visual cortex and then temporals are where we get to hear things. Right? So in order for those receptors to get a message back to that part of the brain that's responsible for interpreting it, it must pass through the optic nerve to cells in the occipital cortex. So if we look at this, actually maybe the next slide is going to be a little bit better. This is what is going on in our eyes. So the optic chiasm, when the optic nerve goes to the brain, it's going to cross. So the right eye message is going to be sent to the left hemisphere and vice versa. And of course, we all remember about the cerebral cortex. So we know that our cerebral cortex is going to be divided into a hemisphere. So if we cut open your brain, it's going to look something like this. Right? You'll have two. And in between that cerebral cortex, it's of course called
Corpus callosum.
Thank you. What allows the right and the left hemispheres to communicate to each other. Okay? So they are going to crisscross at the back. And when we have a block in our visual field, like for instance, my wife is an occupational therapist. She works with stroke patients. That's like what she does. Does everyone know what a stroke is?
Mm-hmm.
What is it? I don't know. Please tell me. Yes, ma'am.
It is when you have a bleed in your brain and it like, I know it like.
That's all right.
It's like when the brain is like punctured with, it like releases blood into the veins.
And when you have a stroke, what can take place is you can have an obstruction in part of this optic nerve business. Okay? And in that obstruction, you can have blocks in your visual field. So my wife talks a lot about stroke patients who had an issue in the brain. Nothing is physically wrong with their eyeballs, right? But due to a block in this cross, the entire right eye, they can't see anything, right? Or a part of their visual field is no longer there. So what I want you to know is that our eyes crisscross in our brain to our visual cortex in the back of our brain. Okay, and at this point we were going to watch a short video, but I think we're going to pause that one because we're going to make sure we have time for this part. All right, now this part's kind of interesting, right? And we'll be able to see this when we get into dissecting that cow eyeball. Our retinas have a hole in them, right? And obviously that means that there are no cells, no rods or cones present where there's a hole at. The hole is where the optic nerve is going to connect to the retina. So we literally can't see it. You right now have a hole in your visual field that your brain is filling in. And we're going to show you where it's at. It's kind of interesting. Okay, so after we have this down, I'm going to ask you to, once you have that, if you would open up your computers real quick, I'm going to send you to a tiny URL that's going to take you to a website that's going to allow you to see where your blind spot is. So please go to this website right now. Yes, ma'am. Phone it up if you don't have it. As long as you're not texting your brother boyfriend back there. Okay? So it's tinyurl.com/L9ZNWGH. And I'm just going to skip this thing ahead. Yep, that's it. That's going to be about it. Alright, we'll freeze that one. Command Control